Good morning, everybody. It's a real pleasure and honor for me to be here. And first of all, let me thank George Velidis, which is the leader of our group. And I guess it's real, so we are very lucky to have scientists like George in Georgia. So, as George told you, I come from Veneto region. Veneto region is the former domain of the Republic of Venice. And my university is located in Padova. The number you see here is not the postal code of a city, but is the year of foundation of our university, which is one of the oldest over the world. I just want to, so we are always proud to recall that Galileo Galilei was our professor in our university. I guess you are familiar with Galileo Galilei, so many times ago. Today I would like, with your help, to try to answer to three main questions. Is it convenient to apply nitrogen variable rate application during wheat? Are there major limitations? And finally, is it feasible coupling weather forecast with proximal sensing to drive nitrogen variable rate application? Can you understand my Italian English? Is good or enough? Okay, perfect. Thank you very much. So first of all, the result you will see is not just only my work, but is a work of a team. So from the University of Padova and from the University of Florence. And they were produced within the Progetto Ager, which is a project which was supported by Italian foundations. So let's start with very simple food stereotypes. If I ask Italians what is the most important food in the United States, they just reply hamburgers, or maybe in Italian English, hamburger. But I guess if you ask you what is the main food in Italy, half of you would reply Italian soup, but the other half, maybe I'm sure, would reply spaghetti, pasta. Yes, pasta is our main dishes. And I don't know if you are familiar with pasta, but the real pasta is made with durum wheat flour. And indeed, it's considered a fraud in Italy to produce pasta, for example, with rice flour or bread flour. Why? Because, the flour of durum wheat has a high protein content and gluten content, which makes pasta with very good cooking quality and stability to overcooking. Italians are very picky about the grade of cooking of pasta, I guess like you with your hamburgers. So, actually, in the past, the main action we took to increase the wheat quality was to work on variety selection and then to nitrogen application. At sometimes, rates almost double when required to maximizing grain yield. But now in Europe we have a major regulation for nitrogen application. There is a directive which is called nitrate directive, which just cap the nitrogen application just to avoid water pollution. And now there are also some problems regarding greenhouse gas effect, which is made during the production of fertilizers. So, since Italian cereal market offers a premium to wheat stocks with very, very high protein content, now we are trying to work on two different directives, so in two different ways. We are trying to apply precision harvesting, which means just to to collect in a different stocks the grain according to the protein content. And it is the topic of today. We just to apply nitrogen variable rate application, just to optimize nitrogen input and reduce environmental impact on water and on atmosphere. I guess more or less you are familiar with so the main way to apply variable rate application. In Italy, usually we apply management zone. Why? Because it's more simple, I would say. But you have a good result only when the spatial variability is strong and the shape of the zone are stable in the time. Because sometimes, so during the years, the shape of the management zone can vary and can become bigger or smaller. So the other system is the real-time sensor application, and it's the dream of Italian farmers. You just go in the field, you have your sensor, you sense the status of your crop, and you apply the fertilizers. But there are some problems. The first one is that commercial sensors are not stress specific. I mean, sometimes it's difficult to separate nitrogen stress from water stress. But most important is that our relationship between nitrogen rate and sensor response must be defined. I mean, I measure, NDVI, so I have a value, and I have to convert this value in nitrogen rate. Here you can see there are different, methods, and nitrogen-rich strip, 2-point calibration method, 1-point calibration method. Actually, I don't want to detail with this method, but I just want to underline that all these methods are based on the fact that more or less we know that there is a relationship between nitrogen uptake and NDVI. For example, here, this is a relationship we measured in Durum wheat. So more or less, we are able to estimate what is the nitrogen uptake at a given level of NDVI value. Here I just want to show how we can use variable rate application. We build a curve of optimal NDVI, for example, with nitrogen-rich strip, so without nitrogen limitation. So according to the relationship you have seen before, we build a curve of optimal nitrogen supply, and then we go into the field. So this is our optimal nitrogen curve, and this is our real curve. So we try to adjust the nitrogen supply. First of all, there is a M2, which is a rate, just to reach the curve with, to reach the optimal nitrogen curve. And then we supply another doses just to reach the final nitrogen supply. So what's the problem here? Is that any method you use to convert NDVI into fertilizer rate is based on weather condition of the past. I mean, if this is the time where I go into the field to apply nitrogen fertilization, I apply N2 and 1. N2 is real because I can sense the real nitrogen content which is needed just to increase, just to reach the optimal nitrogen condition. But I don't know actually what will be the future because, okay, I presume that the curve will follow a medium optimal condition. But actually, if I suffer water stress, the real curve will have a different shape. And the optimal nitrogen supply will be lower. It means that my nitrogen application will have a part of inefficient nitrogen, just because what I have foreseen, what I presume will not be allowed by the weather forecast. So, by the weather condition, I'm sorry. So, how can we improve this situation? So, we try to work on weather forecast, medium-term weather forecast, so 2-3 months. We're working in this way. So we make weather forecast, and in 3 months we apply a crop models just to have an idea of the optimal nitrogen supply. Then we go back to the field, and according to the NDVI and to what we have foreseen as a best nitrogen supply, we apply nitrogen variable rate application. I just wanted to go into detail now, showing a real case of our application. So we work in nearby the Venice Lagoon watershed in a field of about 33 acres. So you can see here there is it is the Venice Lagoon watershed. And so the area is protected. It is considered vulnerable according to the European Nitrate Directive. So the aim of our work was to increase quality and quantity of Durum with mitigating nitrogen pollution. This is the field. You can see there is a large variability with higher sand content in the lower part and lower sand content in the higher part. At the beginning, we apply prescription map methods. So with very high rates of nitrogen for the sandy area, and the lower nitrogen for the high fertility area. We cultivate in Durum wheat in sod seeding. Our combine, so we have a yield sensor, and we have a patent of a sensor which is able to measure crude protein content. So we can have an idea not only of wheat yield, but also of the protein content and of the nitrogen uptake content. So we are able to make estimation of a nitrogen surplus and nitrogen efficiency. This is our sensor. It's based on near-infrared technologies, and it works very, very well. So we are very happy. Just to show you, this is the map of yield and the map of protein content. You can see there is a large variability, despite the fact that we wanted to, just to make flat the difference between the part of the fields. Indeed, we have a very low yield here in the sandy area, but conversely, we had a higher protein content. Why we have a very low yield here? Just because of water stress when the plant suffered in the last part of a cycle, just because we had a very, very high temperature. So if I want to look at the nitrogen surplus and the nitrogen efficiency, you can see that, for example, we waste more than 100 kilograms per hectare, which more or less is under the pounds per acres of nitrogen, just because we base our nitrogen application on a medium weather condition, but we suffered water stress. And indeed, you see the efficiency. The efficiency is lower than 30%. So we waste a lot of money, and we polluted the environment. So what's the idea? The idea is to work with a weather forecast. So we had a general circulation model, which is offered by many international agencies. We just give you what is predicted in the next 3, 4, or lesser months. According to this, the prediction, it's possible to build, a different. It's called in a stochastic way. So it was to be different curve or different series of climate condition, and we used the average prediction just to apply a model, a crop model, a yield model, to have curves of yield and the protein contents. So we were able at least to estimate in the following 3 months what was, according to our estimations, of course, the yield and the protein content. The first question that you have in mind is, were good weather forecast or not? I just want to go very quickly, just to say that, so in general, the trend were good. I mean, this is the average rainfall, and this is the forecast rainfall and the real rainfall. So we predicted an higher rainfall in the following months, even if the quantity of rainfall was higher. The same was, for example, with the temperature, with the minimum temperature. So you see that, okay, the model was able to see the trend, but not the exact values. But anyway, we're not scared about this. I want to show our result and our conclusion. So what we did then, we just to optimize the nitrogen rate in the way to we consider the marginal product of nitrogen, and just that was put equal to the price ratio. So this is a typical way to to optimize nitrogen application. So our criteria was based on economic profit. Here you can see the different zone. This is the yield we predicted, the protein that were predicted, sorry, and the nitrogen optimal doses. Then, so we had the optimal nitrogen supply. Then we went back to the field. We measured the NDVI, and according to the relationship that I've shown at the beginning of my presentation, we were able just to produce a prescription maps. So we went into the field, and so we apply variable rate application. I just want to show you the first result. This is the mean nitrogen applied in the field, so around 160 pounds per acres. And this is what we used to apply on the base of prescription map. Why it is lower? Because the criteria was based on economic, because the nitrogen application was based on economic criteria. So usually is a little bit lower than criteria based on to maximize crop yield. And these are the results. So here you can see that the variability is lower within the field. I just put also here the yield map in 2011 just for comparison. You can see that the variability is lower, but the crop yield is as well lower than 2011. Why? Just because we apply lesser nitrogen. In terms of protein content, we have the same result. So we were able to homogenize the result with the field. But here what you can say, that the average protein content is higher than 2011. Just want to stress that the years are different, but this is just to compare the result, to give you an idea. So, in terms of profit, since we have a premium from the cereal market, the profit, we have lesser yield, but we have higher protein content, so we have also higher profit for result in 2013. What is very important, not too much. For Italian standards, not too much, it's lesser than $10 per acres. But what is most important, we have to consider also the environmental benefits, since the nitrogen surplus was reduced from 61 to 42, and the nitrogen efficiency was increased from 66 to 76. So, for Europe, it's very important, the environmental impact, and so we think that we had a good result. So what about our question? I'm trying to finish my, to go to the end of my presentation. Is it convenient? Are there major drawbacks in applying nitrogen variable rate application? I would say yes, it's convenient. It's convenient, but the convenience depends on the interaction between management and climate, and I would say soil. The variability of soil you take into account when you apply variable rate application, which is the basis of the criteria of our application. The problem is climate, and it's always my grandmother was a farmer, and her main concern was the climate, was the weather. It's going to rain, it will be dry, and so, you know, it is obvious that it's a major problem. The first question, it is feasible coupling weather forecast with proximal sensing to drive nitrogen variable rate application? I would say yes, but I would reply with another question. These are experiments. How can we extend this result at practical level? I would say, how can we extend this result if, for example, my daughter don't trust 3 days weather forecast to go to the beach? So how can we trust 2 or 3 months weather forecast? So what is our vision? How can we translate at practical level these results? In our opinion, we cannot expect to have very, very exact forecast. So just to say that the precision is of 2-3 inches in 2 or 3 months weather forecast. Our idea is just to have a general trend, so dry, medium dry, or average, and then to pick this information from the meteo services to send to the tractor computers, and by means of very simple mental models, just to predict, what will be the yield. Even here, not to predict in a very exact way. Just to say, okay, it will be high, it will be medium high, it will be low. And according to this prediction, just go into the field and fix the optimal nitrogen uptake and to apply nitrogen variable rate application. I hope I don't know if it will be, feasible or not, but we are working on this way because you know, as I told you, so climate is a major element, and especially if you want to increase the efficiency of the nitrogen and the water cycles. Okay, that's all. Apologize for my Italian English, but I hope you understand my result, and I thank you again for your attention. That's all. Any questions? Any questions?
Where do you get most of y'all's weather information for these long-term 2 to 3 month forecasts? Where do you get that information from?
So there are some. Okay, the question is, where did we get the information, the weather information, the 3 months information? Okay, I'm not involved exactly in the modeling activities, but there are, in this case, major weather agency. You can just contact, there is an American as well as a European agency that just provide this kind of information. The problem is to pass from a general trend to daily climate data to run the model. In this case, there is a model, so we apply this model, not me, but the modelers. It is called LAS-WG, is a well-known model, and so that's all. Just to produce this daily weather data, climate data, just to run the model. Second question?
I would like to add something to that, because your question is probably more specific about where you can access information here. So there's a fabulous website that's run by the University of Florida called AgroClimate, A-G-R-O Climate. And you can go there and you can find detailed information about the upcoming trends, expected trends, forecasts for the near term and the long term. And Dr. Ortiz is much more versed in this, so she may be able to provide some more information. Would you like to add something?
In the past, what Auburn University did work where they took Doppler radar information to get specific rainfall quantities in known areas. You could kick it down to your fields and see how much rain was in those fields instead of having weather stations. You can't, even though we got these weather stations scattered out, 80-something across the state of Georgia, still it's thunderstorms roll through, and you may have 3 inches here and 1.5 inches there. The data they were providing from Auburn with the Doppler radar gave us the ability to go down to the field level, so and then we can use our planning of how much irrigation we do. And I was just wondering how they would get your information, because it seemed to be very accurate over.
No, in my opinion, we are not very accurate. So I see you can catch the trend. But, so there are big differences. But anyway, so in my idea, we just don't need to have an accurate forecast. I just want to say it will be rainy, or it will be medium, or it will be dry. Just this information is important for me. Just this information, just to increase the nitrogen efficiency. As you see. So this is my personal opinion, okay.
The gentleman here also made a comment about how in the past Auburn University was able to provide downscale Doppler radar so you can estimate the rain on your property. That has been commercialized now. The company is called Rainwave, and it has been recently acquired by Tremble. So you can look up Rainwave on the website, and you can pay them a small yearly subscription, and they will give you an estimate, a daily estimate of precipitation for the lat long that you provide. We're evaluating the service right now to see how accurate it is and how reliable it is.